The 737 fuel system stores and feeds the fuel to the engines and APU. Not only the routine constructions and components same like the other classic aircraft, but for the relatively long-range operational capability, the 737 fuel system also has the central fuel tank in the fuselage in the inboard section of each wing. Surge tanks found outboard of each main tank collect fuel overflow and fuel from the vent system. The nitrogen generation system removes oxygen in the center tank air to a level which does not support combustion. The 737 fuel storage system provides compartments in the wings to store and transfer fuel for use by the engines and APU. There are 3 fuel tanks, -2 main tanks, 1 in each wing, 1 center tank, in the center fuselage and inboard wing sections. Two surge tanks found outboard of each main tank collect fuel overflow and fuel from the vent system. The fuel vent system keeps the pressure of the fuel tanks near the ambient pressure. Too large a pressure difference can cause damage to the wing structure. Vent channels and vent tubes equalize the pressure between each tank and the surge tanks when the airplane is in a climb attitude. The surge tanks are open to the atmosphere through the vent scoop. Flame arresters make sure excessive heat does not enter the fuel vent system. A clogged flame arrestor causes the pressure relief valve in the surge tank to open. When open, the pressure relief valve becomes another vent for the fuel vent system. The engine fuel feed system uses fuel boost pumps to make fuel pressure for the engines. The 2 boost pumps are in the center fuel tank. There are 2 fuel boost pumps for each main tank, for total. When the central tank boost pumps are on, those pumps supply more than 2 times the pressure of the main tank boost pumps. This higher pressure closes the outlet check valves on the main tank boost pumps. This makes sure fuel from the center tank is used before main tank fuel. The APU fuel feed system supplies fuel from any tank to the APU. The center tank boost pumps or the boost pumps in left or right main tank supply fuel to the APU. If the boost pumps are off, the APU suctions fuel from left main tank. The electronic control unit, ECU, controls fuel flow to the APU. The nitrogen generation system, NGS, separates oxygen from nitrogen from the air and sends this nitrogen-enriched air to the fuel tanks. This system decreases the oxygen level in the fuel tanks and makes the fuel vapor less flammable at the same time. The Fuel Quantity Indicating System, FQIS, calculates the fuel weight in each fuel tank. The Fuel Quantity Processor unit sends excitation to and receives signals from the tank units and the compensators. There are 12 tank units in each main tanks, 8 tank units in the center tank, total 32 units. There is 1 compensator in each tank. The fuel quantity processor sends a common low-impedance excitation signal to the tank units. The tank units return a single high-impedance signal to the processor. This high-impedance return signal is in proportion to fuel weight for the entire tank. The compensators correct for differences in fuel properties. The Fuel Quantity Processor Unit, FQPU, calculates total fuel weight and supplies this to the FMCS. Individual fuel tank quantity shows on the CDS and the refuel panel. Fuel quantity shows in pounds or kilograms. The Refuel Control Panel, RCP, controls operations for refuel, defuel, fuel transfer,